You should have permission now.
I do. I'm recording now.
Oh.
Hello, students. I'm Mr. Carlson.
And I'm Mr. Butterworth.
And today we're going to be looking at the first section that we're going to be looking at in this book, which is called Patterns They're Growing.
So we have 3 designs to start us off. Design 1, which has 1 block. Design 2, which has 3 blocks. And design 3, which has 6 blocks. We're supposed to describe design 4. I'll describe it and then I'll make Mr. Carlson draw it. That seems fair. So design 1 has 1 block on the bottom. Design 2 has 2 blocks on the bottom. And design 3 has 3 blocks on the bottom. So design 4 is going to have 4 blocks on the bottom. 1, 2, 3, 4. And then it looks like it reduces by 1 each layer up. So above that, we should have a row of 3, and then a row of 2, and then a row of 1. Beautiful, Mr. Carlson.
I try.
So it tells us to describe the observable pattern. I think I kind of just did that. It seems like it starts with the design number, that's along the bottom row, and then you subtract 1 for each row above it.
One of the other things that I notice here is that each design also has the same number of rows as the design number. So the first design has 1 row, the second has 2, and the third one has 3.
I like that. I like that.
So it seems like we're going to be doing some stuff with patterns today, and specifically looking at lots of different ways to find and understand patterns. All right, here we can see that we've got a specific pattern based on B's. I want to talk a little bit about the diagram that we see here, because we got numbers on both sides, and that's a little bit weird for us. The first thing I see is that we have the key defining male and female bees as purple-winged and gray-winged respectively. And then on the left side, we can see that we have different generations all the way down to 6 generations from this one bee. And on the right side, we can see that each generation has a certain number of specific bees that if you were to count across, you'd see what that is. So we go from 1 to 1 to 2 to 3 to 5 and then to 8.
And our advice to you is don't get too confused or stuck in trying to figure out exactly how this like family tree type of thing works. Mr. Carlson and I got a little stuck in the weeds. Don't get too confused. They're just using some bees as a picture, and then we're going to play with the pattern.
All right, so now that we've kind of opened up the questions, we're being asked to figure out what's going on in this pattern. And this looks really different from the pattern that we had before, where we're adding kind of a really predictable number each time. This one looks a little bit different in terms of the numbers don't go up evenly, and these numbers seem kind of weird to me when I see this. And I guess in looking at the stuff that Mr. Butterworth just wrote, you know, how do we get from 1 to 1 and then from that 1 to 2? That's what we're trying to figure out when we're talking about figuring out the pattern between these generations.
Well, I can see that if you have a 1 and then a 1, 1 plus 1 is 2. I don't know if that's useful, but I can see that.
So you're saying that, so we got a 1 and then a 1, and then from the second one, we're plussing 1 to get to 2.
Well, I'm saying, yeah, I mean, you could do that, yeah. And then that works for 2 to 3. So 2 plus 1 is 3.
Cool. And from 3 to 5, it'd be plus 2.
Oh.
And then from 5 to 8, that's plus 3. That's kind of weird. So one of the things that I notice here is that the same way that it's changing each time looks like the same numbers that we had in the original pattern. but kind of shifted to the right a little bit.
Hmm.
And I think that's a little bit different than the way that you were thinking about that, because you mentioned talking about the 1 and 1 makes 2.
Yes.
And then you said, and then if you add the 1 again, you get the 3.
Mm-hmm.
Uh,
Oh, and then are you saying if you do 2 and 3, that's 5?
2 and 3 would give you 5.
Ha 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 ha.
And then 3 and 5 would get us to 8.
So does that mean the next number is going to be 13?
It sounds like it, because then if I did 5 and 8, that would get me 13. And if I thought about that in terms of kind of copying this pattern, the next jump would be plus 5, because we're copying the top row, and that would also get us 13.
Oh, yeah. So then we'd have 13, and then we do 8 plus 13.
And
So
we do
that's
that,
21.
21.
Okay.
And then when we do 21 plus 13, we end up with 34. So one of the advantages that Mr. Butterworth and I have over you guys who are relatively new to the algebra world is that when we see these numbers put together, we recognize this pattern as a really famous pattern in mathematics. This is the Fibonacci sequence, and it's been described in a lot of both mathematical and popular texts because it shows up all over the place. But we can see that each number is being built in the same way, which is that it's based on the previous two being added together. So maybe add the last 2 to get the next number. Does that make sense, Mr. Butterworth?
Yeah, you didn't put the word last, but I'll put it in there for you.
Oh, cool.
Last 2 to get the next term.
Next. I was about to leave out the word next as well.
So the mathematical rule might be something like current equals previous sum of previous 2.
Sure.
We could add like specific math language there, but I don't think we need to go there yet.
No, I don't think so either.
Previous 2 terms. Beautiful.
I noticed that you used the word term there, and we haven't used that yet in this math class. Is that just talking about one of these numbers in this sequence of numbers?
Yeah, so like the first term, I'm going to use the laser pointer. The first term is that one. And then the second term is that one. The third term is that one. It matches up basically with the generation column.
Cool. So we could also call those terms as well as the generation.
Yes.
All right, let's see what's next.
So now we're talking about Miriam owning a flooring company. Her latest job involves tiling a square room. Miriam's customer, Mr. Rivera, requests a tile pattern of alternating black, white, and gray tiles. Each tile is 1 square foot. So design 1 has 1 black tile. Design 2 has a black and then surrounded by white. And then design 3 has black and then white and then gray. We're supposed to analyze the design and then describe as many patterns as you can. So one pattern is simply, we're going to alternate black, white, gray. So the next piece around is going to be black.
That was going to be my question. Because I can see some patterns that are happening now, but that would mess up the pattern of just kind of keeping one black square. So then the next row out, we can assume is going to be black all around.
Yes, I think that's a fair assumption because they're saying alternating. And let's see, what if we consider, so for design 1, oops, I need to be on the correct thing. Design 1, we have 1 tile. Design 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. Design 3, we have 9, and then 5 and 5 is 10. and then 6 more. So 9 and 16, so that's 25. So if I count the total number of tiles.
I also see a pattern in the number of tiles that make up the bottom of these things, where if I look at design 1, we have 1, design 2, we have 3 across the bottom, and design 3, we have 5 across the bottom.
Oh, wait, there's a connection between those numbers. You have 1, and then there's 1 tile. You have 3 on the bottom, and then 9 tiles. Then you have 5 and 25 tiles. That's a pattern.
So you're saying that because each of those designs are square, the bottom of the square has to do with how many tiles there are total.
Yeah, look at us. We did something.
Yeah, and this is nice because it brings in some nice geometry stuff. We know what we're really talking about here is area. And to get the area of some kind of a rectangle, we know we do the base times the height, which in this case, they're the same number. So we're squaring things. All right, so here we're trying to figure out what's going on for a 9x9 example. I'm going to start in the center. We have the design from the previous page at the bottom left. And we don't have access to a gray marker using Jamboard, so we're going to use blue to match that. For the black one, oh, I'm making a mess. That's going to be in the center. The next row out is going to be white, so I'm going to not fill those ones in because the page is already white. And then I'm going to make a row of allegedly gray that's represented by blue. And the next row out is going to be black from there. So I'm going to do a row of black things ringing around this, and then we got to go. And the next row out is going to be white. Our squares are already colored white, so we don't need to add any color there.
I think that's all we got to do there. Sounds good. All right, now we have a hotel manager who wants Miriam to tile their lobbies in the same design she created for Mr. Rivera. The lobby measures 45 by 45. So that means we're going to have 45 along the bottom and 45 along the top. He wants the outer edge to be the same color as the center tile. Will this occur? Let's think. So when we had 1 tile, obviously that occurred. But we would have to do 1 tile and then the other tile and then the third tile and then go back. So on the 4th time, we'll be back to the original color. And so we have to figure out, okay, what's going to happen for the 45th? Well, can't we say, and I think Mr. Carlson's writing the colors. Yeah. So in the colors that he chose, we have black, green, blue, and then black, green, blue, and we'll keep doing that pattern. So black and then green and then blue. And what do you think is going to happen? I don't know. So 1, 4, 7. I'm just going to write those numbers down. So we have 1, 4, 7. So 11, 14. So that's a pattern of ones that will match the original color. Does that make sense, Mr. Carlson?
Yes, it does. The only thing that I'm concerned about is that when we have this not being given as like the 45th row of tiles, but that there are 45 tiles in that row. And one of the things that I remember is that the length of tiles started at 1, and then we had 3, and then 5. So in terms of like these being the iterations 1, 2, and 3, but the number of tiles we're not looking for the 45th number necessarily. So I think we got to kind of combine those two things.
So you're saying, let's go ahead and get rid of that I was writing. And let's instead put numbers below. So if I put 1, 3, 5, 7, 9, 11, you made these tighter as the numbers got bigger just to make my life more difficult. I forgive you.
It's also because I wrote 8 in blue instead of green. So there's that.
So 8 goes with 15 and 9 goes with 17. So we have to start thinking about what that pattern is.
When I look at the numbers that are written down in red below, I see all numbers that share the characteristic of being odd.
I agree with that. That's definitely true.
And it also looks like they go up by 2 each time.
Yes.
And I don't know, we've got a pretty long pattern here. I think that means that this is probably going to continue like this forever.
Oh, wait, and we only care about the original color. So we care about this one.
Yeah.
And we care about 4 and 7.
Okay.
So those are going up by 6. If I look there.
So because we only care about those ones, we're going up +6 each time. And the other thing I notice is that up here, we're going up +3 each time. So the next one here, which we already knew, is going to be 10. And going up 6 from 13 is going to be predictably 19.
Yes.
Can we do that without the intermediate numbers for the next jump?
So instead of going up by, well, do you want to go all the way to 45?
Not yet. I'm not entirely convinced that how big of a jump that's going to take.
So if we go up by 3 again on the top, that'll be 13, and then 6 again on the bottom is 25.
Okay. And if we do that again, we got 16 and 31.
So I want to make a prediction.
Yes.
So instead of going up by 3 on the top, I want to go up by 9 on the top.
Okay. And since we go up by 3 each time and not going up by 9 is a multiple of 3.
Yeah, you're right.
That should give us something that works okay. So that'd be 25.
Yes.
There. Okay.
And then if I'm going up by 9 on the top, I have to go up by 6 3 times. So I have to go up by 18.
I also noticed that that's twice as big as 9.
Yes, and 6 is twice as big as 3.
Oh man, but we went too far.
Oh no, what did I do?
So then
we would go back by 6, right? Because I went too far. So really, I just wasted our time.
So you're saying that we could kind of do one that's in the middle here. Because 49.
Instead of going up to 49, I'm going to erase that.
Okay.
We could have gone up by, let's see, we went up by 18, so we could have gone up by 12 instead. So we could have gone up to, I'm adding, and that's hard, 43. And then 22, right? I got that. I don't know why you made that blue.
I don't either.
You big meanie, we're going to make that matching. Okay, so 22. So that's 43, and then the next one would be 6 more than that, which would be the 49 we already talked about. So can we get the 45?
I'd say no, or that it won't be the same color as the inside.
I would agree. Did we do way too much work?
Probably. I think we could do that more efficiently. I think that noticing the patterns that we did, if we were doing this problem again, we could go up by 6 each time pretty quickly and see if that makes sense.
So do you think, I think number 4, I think that they can try to do that. The students can try to do that. And then they can come to class with their ideas and we can see how efficient we can be.
I think that's a good idea.
Sounds great. Y'all have fun with that.
All right, so now we're looking at, we've got an election at the high school, and we're keeping things secret, but as you know, people are not very secret for this. And we've got 3 people who initially know these things. We've got a president, a vice president, and a treasurer, and each day they're going to tell 2 of their friends, or the very next day that they tell 2 of their friends. So I'm going to make like little trees here and just put dots to represent people that have been told. And then what's going to happen is that those people also can't keep a secret. And so this is day 1. I just moved that by accident. Now I'm making a mess of things. That's okay. So on the day 1 after being told these things, we're looking at this. The next day, each of these people is going to tell 2 of their closest, most trustworthy friends. And suddenly we have a lot more people that are being told these things.
So let's look. On day 1, there are 6 people that know. So I'm going to put that next to it. And then on day 2, 2, 4, 6, 8, 10, 12 people know.
And we use kind of a weird thing here because we talked about day 1 as the first day after. That kind of means to me that we're talking about a weird concept that we use in math called time 0, where we have that first day before things happening. And I'm actually kind of glad that we're introducing that here. I think that's a good place to talk about this. So we go from 0 to 3, and then on day 1 we have 6 people. And then on day 2 we have, you said 12 people?
Yes, it looks
Cool.
like 17, but and it wouldn't let me,
Yeah.
so I'm rolling with it. So my question is, if the student set it up as a different table, would that be okay?
And I'm going to try to use my psychic knowledge to guess. Are we going to talk about including each layer being added to it?
No.
Oh,
I'm
okay.
going
You're
to
talking
talk about different days. So if they
about,
set it that way, would that be a problem?
that's totally fine as well. In fact, one of the things that's really confusing about patterns and these things called sequences is that we have to deal with whether we're starting counting by 0 or 1. And this ends up being kind of a surprisingly big deal in terms of setting up problems much later in math that we're really not going to have to worry about this year.
And I think I took a peek at the next page. Don't tell anyone. I think we're going to want the concept you came up with. I think we're going to want that one.
Sure.
Based on their time frame.
The other thing that I was thinking of is that this tells how many new people find things out each day.
Mm-hmm.
This doesn't keep track of the total number of people that know.
That's true.
So I might call this new, and then I'd have to think about the total number, which on the first day would be 3. On the second day, I'd have to add the new people to that to get 9. And then I'd have to add the new people to that to get 21, which is going to be a more complicated pattern for us to take a look at.
Should we take a look at the next page and see what we're asked to do?
I think so.
Okay. Ooh, how many seniors will know the winner of the homecoming election on the 4th day? So based on what we had before, we had 0, 1, 2, 3, 4 is what we're looking at. And our pattern was 3, 6, 12. Oh, I don't know what the next number was. We never found that. What should I do?
Well, I'm looking at the values there, and I see that I'm going up by 3 and then up by 6.
Mm-hmm.
So
So we have to go up by 9 the next time?
maybe, but I also don't like the idea that we're changing things we're going up by different amounts each time.
Oh.
So to me, that means this might not be an adding pattern, but rather maybe a multiplying pattern.
Ooh, we're multiplying by 2. Does that help?
Yeah, because 3 times 2 is 6, and 6 times 2 is 12. Cool.
So then 12 times 2 is 24, and 24 times 2 is 48.
The other thing that I like about the way this question is asked is it's asking how many new seniors. So we don't ever have to add those things together, which is the total column I was playing with on the last page.
Oh, so the answer is just 48 new
48 is the
seniors.
answer. And I don't know about you, Mr. Butterworth, but explaining reasoning for this, if I could see someone make this table and then describe that, to me, that would be explaining the reasoning. It might also be nice if they did something like times 2 to show where these numbers are coming from, or some words like it's doubling each time or something like that.
Yeah, I think that's totally fair. And it's also fair that we ask them to do the next part.
I think so too.
And then we can talk about it in class. All right, let's see. Maureen and Matthew are designing their backyard patio. There will be an entrance and an exit. Oh, that's what those little pieces are. Otherwise, that just looks
Oh,
bizarre.
cool.
The sequence shown represents different designs depending on the size of the patio. Keep in mind, the bigger the patio, the more expensive that's going to be. So you have to hit that sweet spot of it's the price you want and fills the space you want. So let's see. Design 1, we have, let's see. I'm going to say we have 5. And then design 2, we have 8, 9, 10. And then design 3, we have 5 and 3, so that's 15, 16, 17. Well, that's not a terribly helpful pattern that I'm looking at.
No, it's kind of weird.
But another pattern, I just saw, I'm stepping on your toes here, Mr. Carlson.
That's okay.
Design 3 has 3 right there.
Mm.
Design 2 has 2 right there. And then design 1 has 1 right there.
And like going across, design 1 has 3, design 2 has 4, and design 3 has 5. So I feel like we have some patterns that are going on here. And then I like that you talked about that entrance and the exit. Those are kind of separate the whole time.
Yeah, so I just kind of ignored those where it's, I mean, basically we could consider it as design 1 is this. So that's design 1. Design 2 is this. And design 3 is 1, 2, 3, 4, 5. 1, 2, 3, 2, 3.
So we have 3 and then 8 and then 15.
Yes.
Which still gives us the same doesn't look quite right things.
But if we think of this, I don't know if this is helpful, but this is 1 times 3.
Mm-hmm.
This is 2 times 4.
Mm.
And then this is 3 times 5. And there is a relationship between those numbers.
Yeah, so it's like the first ones, so the 1, the 2, and the 3, that's the pattern, they're the design number.
Yeah.
And then from 1 to 3, and from 2 to 4, and from 3 to 5, that looks like that's the same change each time.
That seems useful.
So, I don't know, let's say we had design 4. Would that make sense that we'd be doing 4 for the first number?
Mm-hmm.
And then each of these seems like we're adding 2. So would that be times 6 for the second number?
Yes.
And
but
that
then we need the 2 extra, basically.
Okay.
If
So
we're
then
looking at specific numbers.
So thinking about that for each of these, would it make sense that this would be 3 times 5, and then plus 2. And this would be 2 times 4 plus 2. And then 1 times 3, and then plus 2.
Yeah, and I'm writing down the bottom here. That's plus 5, then plus 7, and plus 9.
Oh, because this would be 24 plus 2 is 26.
Oh, and that matches that pattern.
Cool.
Look at us, we found some stuff.
Yeah, we found a whole bunch of stuff. All right, let's see how we're going to be using this. Ooh, we're sketching design 6. So just to kind of reiterate what we did, we had 1 row times 3 boxes for the first one, and then we added the 2 pieces. For the second one, we had 2 rows times 4 boxes, and then adding the entrance and exit. The third one would be 3 rows times 5 boxes, plus adding the entrance and the exit. So if we're asking for the 6th design,
So
would it
I'm
make...
going to fill in this entrance here.
Okay.
But then we're going to have 6 rows.
Yeah.
So we're going to go 6 down. 1, 2, 3, 4, 5, 6. Hope that I counted that correctly. And then how far over do we go?
Well, if we follow the same pattern, we add 2 to that number. So 6 down and then 8 across would make sense.
So something like this. Oh, I feel like I'm coloring. I like coloring. Did I do that correctly?
Assuming that that's all filled in. There we go. I was confused by that a little bit.
It was a little delayed.
That's some excellent art you have there.
I've been practicing with my 5-year-old.
And
then we need the exit.
I got that. Oh, you got that.
You can't change colors on me, Mr. Carlson. You just ruined my beautiful patio.
There we go. I ended it.
Good.
Okay. Cool. And just for funsies, we can guess that would have 6 times 8 is 48, plus 2 is 50 tiles.
That sounds great. And I heard that they should do the last one there about Matthew, where he has 170 tiles. I think they can figure that out and then ask us some questions in class.
I think so too.
Sounds great.